So we looked into different type of algorithms and different problems which are solved using supervised learning and unsupervised learning methods. Now let's look into some algorithms and we'll actually write the code of these algorithms and we'll see how these algorithms work and we'll implement them in Python using sklearn. So let's get started now. So the first algorithm which we'll be seeing is k nearest neighbor. There's a supervised learning class there's a supervised learning algorithms which is used for classifying objects or call we can say it's used for classification problem. It's quite easy to start with that. Suppose we have two classes, class A and class B. Suppose they are two-dimensional data, that's why we can plot these two classes on the XY axis. So the algorithms work like that. Next, first step, we have these points in our XY plane. Next, whenever we have the new data point which we want to classify as either it is A or B, then we calculate the distance, the Euclidean distance from that particular point to all of the data points available in our data. Then this K, which is one of the number which we give, and it depends on different, our accuracy will depend on that particular number. So let's just say K is for now 3. So we calculated all the distances from that new point to all the old point in our data set, and then we stored this information, and then we sorted this distance from this new point to all of the data in our point, and then we picked the first three distances which were the least distant from this new point, and then the class which is maximum uh, in this k first distances, then we say okay, this new point belongs to that class. Suppose our k is 3, then the first 3 point closest to this new point, whatever class they have, then our new point will be classified as of that class. If the k value is 5, then whatever the maximum class is inside this closest 5 point will be categorized as the class of this new point. Usually the value of k is taken as an odd value so that we don't have a conflict of even classes. So as we talked about these distances between these 2 points, right now we were talking example in XY plane, but the same principle can be applied with different features. Suppose in the iris dataset we have the features with four features, then our vector have the four features. So these distances we cannot visualize in XY plane, but the algorithm will remain the same because it uses distances as a parameter to judge how close that point is. So this distance is nothing but Euclidean distance that can be calculated from any point to any point, if it can, the formula remains same for even the four features vector. So let's look into how it works. So as we talked earlier, according to this value of k, all the closest points, the class of that closest point will finally determine the class of this new data point. This is how we do classification using k nearest neighbor. So let's try to use the k nearest neighbor from the sklearn library and make a classifier in our iris dataset code. So the code will remain same till this point for every other algorithm because this is the pre-processing part. This is where we generated the data, and now all the algorithm which will be implementing will only change below this. So the first thing we need to import the k nearest neighbor from sklearn dot neighbor import k neighbor classifier. Our model is k nearest neighbor classifier. It's a we made the new instance using the name model. Now in this model, we'll use this fit method, which will train our model, and it will take the data as x and y. So we have this x train will give as a x value, and then we have this y train where we save the targets. It will save the it will try to fit the model according to this data. Then once our model is trained, now we'll use the model to predict the values in our test set. So model.predict then, and then we give it the x test. Now our expectation is that the classes which are in prediction will be similar to what the classes and the targets are in the y test. Now we talked earlier about the confusion matrix. So in the sklearn, we can get that confusion matrix too from the matrices inside the sklearn. Import classification report. This will give all the information, the precision recall F1 score, which we can generate, which we wanted from the confusion matrix. Now this will require one instance. Let's call it here inside of a print, and this will take our y test, which are the real values, and once we predicted as an input. Let's try to run this code, save it, and then let's try to run this. So as you can see, we have got the precision, the recall, the F1 score for different features for 0, 1, and 2. Support here means how many values were of this class in our test. Let's try to print our predict and also print our y test side by side so that we can actually see how good our model is working. So this is how our model works, but later is in the dictionary. So let's try uh, to print it inside. Okay, let's just see it here. Yeah, so the first two of which we predicted were 0, and the real ones were 0, 2, which mean are of some class which integer value is 0. Then we had the 1 as a class. This is our prediction values, and this is the true values, the true class values. So our model looks good, and this is how the classification works. We predicted these values. Model never saw what the real values are. It only predicted it from the given features, and it looks quite good. So this is how we use k nearest classifier to make a classifier in using sklearn.